Okay, so I did mention some buzzwords, so I guess I'm gonna speak about one of these buzzwords, which is an AI. And a big part of what we're doing at Lightricks is an attempt to democratize creativity. Okay, and for us, creativity and content creation starts with really simple things like taking selfies, like a bunch of people here did in the beginning of the conference, and uploading them to Instagram. Content creation for us continues with the tools for businesses and brands that want to tell their story with the photos and videos, and it continues even further with tools for artists who want to create on mobile. And a big part of figuring out how we can democratize content creation is to figure out how we can eliminate the steep learning curve associated with the existing professional design tools. Okay, so let's start with an example of the kind of a problem that a product researcher at Lightricks might decide to tackle. So what you see is an amateur dance performance that was captured on iPhone. And let's say we want to add some special effects that somehow intrinsically connected to performance, maybe something like that. So until now, if you wanted to achieve these kinds of results, you need to understand After Effects or a bunch of other professional software. And these days, we're getting to the point where everyday user can download an app from the App Store and to get these kinds of results. And what really helps us to bridge this gap between professional software and what everyone can do is advances in AI and machine learning. So, interestingly, we hear a lot about how AI is going to replace this or that job. But I think internally in Lightricks, our thesis, at least in the domain of creative tools, is quite different. We really believe that what we're going to see with machine learning is that it is going to simplify a lot of things. Okay, it is going to make tedious tasks really effortless. And I think the most exciting part is that it's really going to augment human creativity with the tools that are just more powerful than we ever had before. And today I want to show you some real-world examples of where machine learning and AI already changes the nature of design tools. So some of these examples are coming directly from the apps that are available on the App Store, and other are ongoing research projects either in Lightricks or in other places in academia. Okay, so I'll start with a simple example. And people in the computer graphics community for many years were fascinated by this idea of trying and to bring photos to life. Okay, so let's say you have a still photo and you want to animate it. You want to position a virtual camera inside the photo and move there, maybe to get a result like that. So in order to achieve that, we need to understand the coarse or approximate geometry of the scene. And typically the way to achieve that is to understand the relative depth of each pixel in the image. And these are hard computer vision problems. So far, in the professional tools that we had, there was a whole lot of manual work involved. So what you're seeing here, let me go back, is a snapshot from a high-end plugin on top of Adobe After Effects, where the user actually needs to manually create a coarse geometry or paint depth, and it's obviously not an intuitive interface, right? It's really tedious, it's complex, it requires a lot of expertise, and we want to change that. So these days, these manual steps of painting depth or creating coarse geometry are basically obsolete. We got to a point where machine learning is good enough to create depth maps automatically, and then all the interaction that is required from a user is basically just choose the kind of motion that he wants to have in the scene. So here is another example of these, subtle motions of changes in the perspective from next iteration of one of our products. Okay, even more complex task is trying to animate stochastic natural phenomena such as waves, clouds, maybe even trees. And to get result like that, you're seeing the subtle motion of the water. And in order to achieve that, even before the physical simulation of the water, we need to obviously understand in the image where the water is, where the skies are, et cetera, et cetera. And again, we are getting to the point where these tools become really effortless. So that's another example from the app that we have on the App Store. As you can see, the detection of the water and the simulation is not 100% accurate yet. So the user has this small brush where he can fix the mistakes of the machine learning algorithms. But again, we're getting to the point where most of the tedious work is done by this machine learning system. You're obviously welcome to play it by yourself. And here are more examples of the subtle water motion that is facilitated by machine learning tools. Okay, but let's go back to the example we started with, special effects that are connected to human performance. And this is actually an example that inspired us to look into it. I guess some of you saw this kind of movies on Instagram recently. So we tried to figure out, again, and this is achieved by hours on hours of work in After Effects. So we tried to figure out how we can take something that was captured by, again, everyday user and the iPhone and to try to bridge that gap. So these days we have two strong kind of machine learning boxes that helps us to achieve that. First one is a deep neural network that at each frame allows us to understand where exactly the human actor is. And once we have that, there is another deep neural network that helps us with pose tracking. So basically, it gives us an exact localization of each limb of the human body. And once we have these two combined to actually create special effects that do something cool with this, it's not that hard. Again, it's a research prototype, so sorry if it doesn't look that cool. Okay, we're at some point going to pass it to our designers inside Lightricks. But again, these building blocks that are based on deep neural networks do all the tedious work for us. So that's just a bunch of other examples of kind of toy prototype that we're playing with. Okay, now let's discuss some existing photo and video editing tasks that aren't that complex to begin with, but they're quite tedious. So one such task is just selection. Frequently, when we work with Photoshop or other similar software and edit images, we want to select some pixels while leaving other pixels outside the mask. And let's say, for the sake of the example, we want to change the sky in this image because it looks kind of boring. Okay, so that's the end result that we want to get. So accurate selection might be quite a tedious process. With let me go again back and see how it was typically done in Photoshop. Right, so historically we had the lasso tool, right, where we had to spend quite a lot of time selecting, etc. Obviously, these days we have much more powerful selection tools, but think how cool it would be if we just could say to a software, well, you know what, select the sky, or select a plane for me, or select any other object. So we're not there quite yet. We don't have a selection, like general selection mechanism where we can say, select something in the scene for me. But deep neural networks are getting to the point where semantic understanding of the image is actually good enough to select at least some big pronounced object in the scene. And the sky is actually easy enough that it's already integrated in existing products. So again, that's an example from an application that you can download from the App Store and see how it automatically can change the skies for you. And actually, these deep neural networks are becoming really efficient. So a year or two ago, we had the problem that we actually couldn't run these deep neural network on mobile devices. And these days, we're actually getting to the point where it's plausible to run these networks in real time on video. So here you see an example from a sky replacement paper that a research was carried by guys at Lightricks Research and folks from Hebrew U. And again, it's pretty impressive. We couldn't have these results even 2 or 3 years ago. Okay, but I think the most exciting part is actually trying to figure out what kind of applications we can build that leverage these new machine learning and AI tools and allow us completely new kinds of interactions that we just didn't have before. So, first example I want to show is actually something that's connected to selfies that a bunch of you again captured in the beginning. So, in Lightricks, we have this product called Facetune, which is basically a mobile retouching tool that became quite famous. And one of the things that we noticed there that artistically or aesthetically, most of the, or a lot of the selfies that people capture are quite boring because in most scenarios, the lighting sucks, right? I mean, think about it. If you're a professional photographer and you have an access to studio and you know how to set up the lighting, you can get like really amazing results pretty much from every human face. You can highlight certain things, you can do a really cool job with that. So we had this idea of, well, you know what, maybe let's try to simulate this process in software, right? Let's try to figure out how we can get the same amount of control over lighting without actually having the physical setup. And again, it's a hard computer vision problem. We need to do a bunch of things here, right? I mean, we need to start with understanding where the face is. It's actually quite easy these days. Then we need to figure out where the prominent landmarks of the face are. That's, again, not that challenging. Then we need to recreate a 3D geometry of the face. We need to create an actual 3D model. That becomes, that's still kind of not trivial task. But after we have a geometry, there is another step where we need to understand at a per pixel level how we separate between reflection, between the lighting and the kind of innate texture of the albedo of the skin. And that's actually a hard computer vision problem. So until a year ago, existing algorithms weren't just good enough to be a production quality. We couldn't integrate them into real-world products. But again, with the advent of efficient deep neural networks, these days we're actually able to do it on a device, right? To create all these steps that I outlined for you. So again, that's an example from a real-world product. Let's say we want to change illumination. So what you're seeing here is in the UI, these are like free light sources that you can choose. You can move them around. You can play with the hue. And it just creates a new illumination of the face. I think it's really cool. Again, just a couple of examples that our users created with this feature. So again, the effects might be subtle. I don't know if you're seeing them well on this projector, but it really can take a boring selfie and give it quite a lot of character. Okay, another unexpected tool. So at some point we started to have a collaboration with the New York Fashion Week and with designers, and we tried to figure out what cool interactions we can take from this world and to bring to everyone. So one of our researchers had this idea of trying to manipulate the texture of the garments, again, in the post-processing. And again, what actually allows us to do that is, first of all, that we have a deep neural network that says us exactly where the clothing, where the garments are. And then we have another network that allows us to manipulate the properties of the garment, right? So the end result can be something like that, okay? And again, it's really cool. It's achieved in post-processing, and it gives you really a new capability to try to imagine kind of the physical properties of the garments without actually doing anything in the physical world. But people in academia take it even further. We recently saw this paper in ECCV that allows you to, for example, take two models and switch the clothing between them. So as you see, there's like the model on the left, right, the model on the right, and then we are automatically transferring clothing from one to another. So this specific prototype is not production ready yet. As you're seeing, it's quite low res. I mean, it uses an architecture called GANs, and that's something that these days is still constrained by the resolution. But in a year or two, we're going to get to the point that these prototypes, again, are going to be available to everyone on the App Store. So that's another example of that. And yet another example of garment transfer. I think it's super cool. Okay, another prototype that I want to show you, a work by Joint Park. Again, I think it's really inspiring because it shows you to what degree you can simplify the interactions and to get an amazing result. So let's look at the kind of a middle row. And what you're seeing here is, again, we have a human face and we want to change its appearance. So we have this super simple scribble-based mechanism where we are just, drawing a little bit of outline of the kind of different hair, and the system generates the new hair for us. So just think about it. In order to go from the first image to the last image, before you had to have some really mad Photoshop skills, right? And again, these days, everyone can do it with the super intuitive interface. Okay, another example of this prototype, it can even change jewelry. So let's say we're not happy with the jewelry that this lady has in the bottom row. So again, we just can create a rough outline of the kind of jewelry that we want to see here, and the system generates the results for us. Okay, so last cool example that I want to show you is this nice merge between two creative themes that we mentioned today and that we saw in the presentation. One is the human face, and another one is animating still images. So in this cool work by Zakharov and colleagues, they animate historical figures. And again, it doesn't require any kind of user input. Everything is automated. And yet again, these kind of attempts existed in computer graphics community for many years. But finally, advances in machine learning and AI are getting us to a point where these tools are becoming user-friendly enough to be available for everyone. Okay, so I hope I was able to convince you that we have a really good reason to be excited about what AI and machine learning brings to the table to augment human creativity. And thank you.